This video explains Euler's identity, the famous equation linking 5 fundamental constants of mathematics. It's celebrated as one of the most beautiful results in math and forms the foundation of complex analysis, signal processing, and quantum physics. You'll learn to interpret the imaginary exponent, visualize rotation on the unit circle, and see why e to the I pi plus 1 equals 0. We'll start with Euler's formula, which says e to the I theta equals cosine theta plus I sine theta. This traces the unit circle in the complex plane. Plug in theta equals pi, a half rotation, and we land exactly at -1. Let's see how it works on the diagram. Euler's identity. E to the I pi plus 1 equals 0. 5 fundamental constants. One elegant equation, often called the most beautiful formula in mathematics. It looks mysterious. How can an exponential of an imaginary number give -1? The secret is that complex exponentials don't grow, they rotate. Goal: understand why e to the ip equals -1 by watching it as rotation. Step 1. Euler's formula. E to the I theta equals cosine theta plus I sine theta. This is the gateway. The exponential of an imaginary angle equals cosine plus I sine. Its magnitude is always 1 by the Pythagorean identity. So as theta varies, e to the I theta sweeps around the unit circle in the complex plane. Now let's see what theta means as a rotation. Step 2. Theta is the angle measured from the positive real axis, going counterclockwise. When theta is 0, we're at the point 1 on the real axis. A quarter turn, theta equals pi over 2, lands us at I, the top of the circle. And a half turn, theta equals pi, takes us to the other side. Where does that land? Half a turn around the unit circle from 1, that's exactly -1. Step 3. Substitute theta equals pi into Euler's formula. E to the I pi equals cosine pi plus I sine pi. Cosine of pi is -1. Sine of pi is 0. So e to the ip equals -1. Add 1 to both sides, and we arrive at Euler's identity. E to the I pi plus 1 equals 0. Whenever you see e to the I times an angle, think rotation on the unit circle, not growth. Euler's formula turns angles into points. A half rotation from 1 lands at -1. Euler's identity unites e, I, pi, 1, and 0 in a single equation. 5 fundamental constants, perfectly balanced.